Well, hello there. Since the news are really depressing lately, I thought this wouldn't even be possible with COVID and everything, but it's possible apparently. I figured I'd take care of some flat earth stuff. And Gary has been kind of annoying lately, not only with his rubber band thingies that he's still trying to push, but also he's been kind of annoying at Mr. 42. And I cannot let that slide, Gary. So we will stay fully professional. I will not call you any names or anything. We will just look at your problems. Well, some of your problems. Specifically the ones you have with triangles and rubber bands. In case you're not following Gary Wybenga, why bother, Lybenga, whatever his name is. In case you don't follow him, he's trying to explain the fact that ships over the horizon or driving over the horizon appear to disappear from the bottom first with simple rubber band perspective shenanigans. They're not even experiments. Um, I don't recommend watching the original videos, they're quite boring. So I've recreated what he tried to do with this first image here. So in his experiment, he created two triangles of a fixed ratio. So the blue side of the blue triangle always has the upright side of one arrow height, sorry, and the orange triangle always has this right hand side with 7 arrows of height. And if you form a triangle by increasing the distance there, which is shown by the gray arrows on the bottom, you can form two angles and you can measure those angles, which he has done, to be fair, and which I've done and shown here as well. So what he's showing now in his next bit is that he's increasing the distance. So he's basically increasing the side next to the gray arrows here by doing this. So I've just doubled the distance here in my experiment, and lo and behold, both angles get smaller, which is kind of obvious, really. What Gary is claiming now is that the lower angle, or the smaller angle rather, the blue one, gets smaller faster somehow than the orange angle. And he never actually shows this, he just claims that it is so. And based on that assumption, he claims that since the smaller angle gets smaller faster, that somehow explains his bottom-up obstruction thing, because then in his world, the smaller triangle gets smaller faster, and that somehow explains bottom-up obstruction of ships. But when you actually do the math and you increase the distance, increase the bottom side of both triangles, you can see that both angles here, the orange one and the blue one, they both approach a ratio of 7:1, which is kind of interesting. Well, not really if you can explain triangles, because the opposing sides of those two angles, the blue one and the orange one, both of those sides have the same ratio, 7:1. So it's kind of obvious that the corresponding angles show that same ratio. So no, Gary, the smaller angle does not get smaller faster. They get smaller, both angles get smaller, but none of them get smaller faster somehow, because you're only stretching those angles out. So you're doing nothing more. This is simple geometric perspective, shall we say. What's also a fact of this simple geometry is that the blue angle there will always stay positive. It'll never get zero. And Gary cannot explain why a positive angle, however small, can explain bottom-up disappearance of things, because things disappearing means they have an angle of zero because they are not visible. Gary then always tries to explain this away with Rayleigh criterion. I bet he doesn't even know what this actually means. But anyway, he tries to explain this away with, things getting too small to resolve. Although then the same thing should be true for that orange, for that orange angle up there. Because when you stretch those triangles out infinitesimally, both angles get infinitesimally small. So Rayleigh criterion should apply to both of those. But when we look at actual footage of things, footage of reality, we see something completely different. This is a zoomed in version of his footage where the videographer is zooming out. So this is going to get more and more pixely, but we still see this 1-to-1 ratio of the ship, although we have zoomed out quite a bit from the image from just a few minutes ago. When we do that again, now the camera has zoomed out even more. The image is more wide view, therefore that small section of the image gets more pixelated, but I can still see a tiny bit of that superstructure there, the white part, and I can still see this edge of the bottom of the ship. So the ratio stays the same whether you zoom out or you zoom in. Zooming in or out doesn't change the ship that's physically there. It doesn't change anything. Another thing that's really interesting that Gary hasn't even addressed yet is that ships start to disappear bottom first only at a certain distance. So what do I mean by that? They start to disappear, get smaller and smaller when they sail away, and then at a certain distance, which is coincidentally mostly around 3 miles or something, no matter where you are on Earth, which is also kind of interesting, ships start to disappear or to reappear in this case. So this ship just made a nice curve to go into harbor, and it now starts to reappear. And it starts doing so quite smoothly, quite nicely. There's no aberrations of any sort. This is a really clear day. There's ships in front of that, and we see more and more of that ship appear. And then something interesting happens. We don't see any more unobstruction with ships coming back. Now we see the full ship coming in because it has crossed this magic horizon line somehow. And Gary's triangle model doesn't even begin to explain this. That this bottom-up obstruction thing doesn't start right away when a ship sails away or sails in. It starts at a certain distance, which completely corresponds to the globe theory, of course. But he can't explain that. And last but not least, another thing that his triangle shenanigans don't even begin to explain is that not only the ship's bottoms appear or drop, but the whole ship, the superstructure as well, drops, as we can see in this footage. So this is also a video. I will link this in the description. This is a still from a video, but it shows quite nicely how the further away ship, we can't even see the hull of the ship, we only see the containers on top. But the containers are way lower than the ship in front. The top containers barely get to the top half of that ship in front. How is that? The rubber band perspective things with angles doesn't even explain this. How does this work, Gary? So, to summarize again, here are Gary's problems. the list is not complete by a long shot. But here are the three things that I thought were kind of interesting and I showed today. So, first of all, angles always decrease relative to their size, or the size of the opposing sides in triangles. This does not explain anything about how ships disappear or how about anything that we see in the distance looks in reality. Number two, the bottoms of ships start to disappear at 3 miles for a 6 foot tall person away, not before. Also, triangles and rubber bands do not explain this at all. And thirdly, the whole ship seems to be affected when it crosses that magic 3 mile line. The whole ship drops, not just the bottom. Interesting. So, let me make this abundantly clear. Rubber band triangle shenanigans explain none of these problems that I've just shown. When we suppose a globe, which has been proven for thousands of years now, all of those three issues are explained perfectly well. So, with this, I wish you a good night or good morning, and take care, have a good time, and I will see you soon. Bye bye.